Hello, everyone. Again, I'm part of the Google research team, specifically with the Google Flood Forecasting project. I will talk a little bit about generally what our team is doing in other arenas than flood forecasting, and then specifically how do we do the flood forecasting, what are our models, and what tools are we using. And then I will show you the Flood Hub, the Google Flood Hub, that includes all our flood forecasting information, which is publicly available. It can be used by anyone. It's available on desktop. It's available for mobile. And the general idea is to make all the information that we do here based on models and very deep research, make it available for people in flood-prone areas and organizations and governments and so forth. Please feel free to stop me if you have any questions. This is a very, very high-level summary of projects that we do under the climate arena. Generally speaking, the Google research teams dealing with machine learning projects, and we try to see, based on data that is available, based on remote sensing, we try to see how we can contribute into adaptation projects or mitigation projects under climate. Just in high level, we have a flood forecasting project, which I will show you in a minute. We have a wildfire detection project where we also research how we can identify propagation and early detection. Greenlight is a project that we work with cities to improve traffic light timing to reduce waiting time, what will reduce the pollution. Sky is a project that allows us to see in a building level after a big disaster what building was infected and what's not. We have an earthquake project. Open building datasets is specifically, by the way, started in Africa in our African office in Accra, and allowed to identify buildings on Google Maps based on satellite imagery. It's now mapping all of Africa and parts of Asia. This is an open data set that can be used by everyone. We have a low-cost project identifying where locusts are going to arrive in regards to food security. We have projects around global development, agriculture, and food security. Those are a little bit lower level of research, climate and sustainability, and disaster management. When we talk about the Google Flood Forecasting project, we divide it into three parts. First, we have hydrologic model. All our models are AI-based, and we try to make it very global, so not only in specific areas. The hydrologic model is doing what every hydrologic model predicts. It actually predicts what would be the level of the water in a specific location at the river, but in the future. We do that on specific points around the world. We have 1,800 locations that we cover now, and we aim to grow more. And that actually predicts how high the water are going to be at the river in the next up to 7 days. The next model is the inundation model, which predicts how the water are going to be spread out once the river is in a specific level. All of these, by the way, all our forecasts are only on riverine floods. We are planning to work on other types of floods like flash floods, but this is not yet available. So I'm going back to the inundation model. Once we have the forecast on the hydrologic model, like we expect that the water are going to reach a specific return year period in the next 2, 3, 4 days, we can generate a map of how the water are going to be spread on the ground, and by that to identify what are the populated area that are going to be flooded and not. The output of this is actually a map, and I will show it in a minute. The third component of our project is how to deliver this information and make sure it's available for users, for organizations, for governments. We have the Flood Hub, which is here on the left. I will show you in a minute a demo of it. And we also have those alerts available on Google Search. So actually users in flood-prone areas, if they search for the word flood, they can see all the information that we provide that includes all our flood forecasting. Users who have Android phones will also get push notifications to their phones based on our alerts. This is now available in India, Bangladesh, and Brazil. It will During the summer, we're going to go to many more countries, starting with Asia and then going to Africa and South America. And this is also available over Google Maps. Oops, sorry. Yeah. So what is our global model? What we actually did when we started with India and Bangladesh, and how we went global. Uh, we had our very specific flood forecasting models that was based on river gauge measurements. We were able to receive from the Indian Water Committee and from Bangladesh Water Committee real-time measurements for river gauges. But we found it very hard to scale to other locations because there are some locations, for example, in Africa, that just doesn't have river gauges, or the data is not available for us. And we decided to move to global data sets. So we use weather and precipitation data sets and so forth. But all this data is implemented into our hydrologic gauge model, which is AI based on machine learning. And we found out that we are able to provide forecast up to 7 days ahead. And that actually provide us to grow to many more locations. That's general perspective. And again, the fact that we're using machine learning is kind of new in the hydrologic arena, that allow us to scale much faster and to actually learn from places that we have more data to areas that have less data. And Africa is one of those places where we have less data. So this is the Flood Hub. I will, if you don't mind, I will just go into this link. It's just the link g.co/flood hub, and it's available for everyone. Be sure. So now I'm sharing that. Do you see my screen? It's a big map. So this is actually the Flood Hub, and you can see here the gray, yellow, red areas are areas that we have, and the green, gray, red, and yellow areas are areas where we have gauges that we have prediction. You have here a legend. Gray means that there's no data. It's basically in India and Bangladesh where we rely on government's data. We expect to start receiving data when the monsoon season starts, which is in about 2 to 4 weeks. Green means that based on our forecast, there's no forecast for any unexpected event. Yellow and red represent 2 years return period and 5 years return period of hydrologic forecast. And we will try to deep dive to see some examples. So, for example, I can see here that in DRC and also in Angola, there are some areas. All the pins are actually gauges where we have forecast for. And if, for example, I click on this gauge, I can see here the actual hydrograph for the gauge. So the left side represent historical data. It's a nowcasting that our model generated. And on the left side, so we can see that in 8 hours, in 3 days, in 4 days, we have a forecast. This is how the water are going to change. Actually, no real change, but it's all dramatically above what we call danger level or warning level. Those again represent 5 years return period and 2 years return period. And if I go by the gauges, I can see the different hydrograph, which usually looks pretty much the same when you look at the same river. If I go to a different basin, I might see a different type of hydrograph. Okay, so here there is some expectations for the water to go down, and then if I go down in the river, usually it looks pretty much the same, but a little bit different. When I zoom in a little bit, I can see the actual inundation map. So here we can see that this is basically the river, but those are the areas that are flooded. And sorry, if I zoom out a little bit, I can go along the river and see that there are a lot of areas that are flooded at this time, given the fact that the water are high at the gauge. We have here some more examples. For example, here you can see that there's a big lake and there's a small river around here, but there's a lot of areas that are flooded around that. And this is all available on the maps. The maps are available only when there is when the gauge is going above warning level or above danger level. Not all areas have inundation maps. Specifically in Africa, most of the location does have inundation maps. In areas like Europe, we have only hydrologic forecast. And in some locations, specifically in India and Bangladesh, and we plan to grow to more areas, we will also have depth information. So we will be able to zoom into specific location where we will have here information about how deep the water are in reference to the body part. I don't have an example here because it's only in India and Bangladesh and it's not the season there yet. But this is also sometimes available and allow you to give to receive information on specific locations how bad the flood is there. That's it for now. This is the information. Oh, and also you can see here, so here's the forecast in text. We're also going to change it to be a little bit more visual, like how the water are going to change in the future. Any questions? I can also share a little bit information on what we're planning, but this is in a general statement of what is the flood forecasting information that we have around the world. Again, we have stations in 79 countries, covering 18 stations, around 460 million people that are living around these areas. We are in search and maps in some countries, and we're going to be available also with search and maps notifications in many more countries during the summer. And again, the Flood Hub is available for everyone.